From multi-purpose single platforms to coordinated clusters and cross-domain integration, the practical applications of robot wolves continue to expand. The coordinated use of ground-based robot wolves and aerial drone swarms has given rise to a new, highly integrated intelligent operations model. This combination of aerial bee swarms and ground wolf packs represents a technologically advanced approach that feels almost futuristic. The aerial swarm can first provide wide area suppression and situational awareness, observing large regions and engaging multiple points with precision. Meanwhile, the robot wolf pack can maintain effective control over the forward operational zone. Personnel positioned safely in the rear can use the aerial swarm to remotely coordinate and direct the robot wolf pack's actions. This approach can significantly reduce risks to human operators while helping penetrate defensive systems and counter traditional operational structures. The combined use of aerial swarms and robot wolves can provide the employing force with greater initiative and operational advantage. In recent years, units across the force have actively adapted to evolving operational requirements by incorporating portable unmanned systems training into routine exercises. They have explored new methods and tactics centered on unmanned and intelligent technologies, applying these findings to practical training and enhancing overall operational capability. During a multi-branch comprehensive exercise conducted by a brigade of the 82nd Group Army under the Central Theater Command, unmanned reconnaissance, precision strike support, and communication systems were integrated to evaluate the unit's overall combat readiness under realistic conditions. In the exercise, reconnaissance teams used drones and unmanned ground vehicles to survey routes, robotic quadrupeds helped overcome obstacles, and assault elements advanced quickly to secure positions and push deeper into the designated area. In another UAV flight training event, the long endurance and high-precision sensing capabilities of unmanned aircraft enabled personnel to monitor targets in complex environments in real time, significantly improving reconnaissance and early warning performance. At the training grounds of a brigade under the 83rd Group Army, a coordinated man-in-man combat drill is also underway. By establishing a multi-layered reconnaissance network including drones, portable radar systems, and unmanned vehicles, personnel can rapidly acquire battlefield information and maintain operational initiative. In the UAV training facility, service members also use simulation systems to practice in realistic digital environments that replicate varied terrain, weather, and electromagnetic conditions, helping them better understand UAV flight fundamentals. Through simulation-based training, a structured experience system is created, allowing participants to complete hundreds or even thousands of virtual engagements beforehand and quickly translate that experience into practical intuition and operational proficiency. Over the years, the brigade has integrated unmanned systems into diverse training formats and developed a comprehensive set of tactics that effectively combine firepower, reconnaissance, and other elements within a man-in-man coordinated framework. These coordinated tactics enable the force to deliver system-supported, multi-layered effects, providing enhanced situational awareness from above and improved protection on the ground, greatly strengthening overall combat capability. At an Army field training site, an infantry squad drill focused on UAV-enabled offense and countermeasures is currently in progress. During the advance, the unit was suddenly suppressed by an enemy firing position, and reconnaissance revealed a concealed sniper ahead. The commander decided to deploy a low-altitude, high-speed unmanned platform to neutralize the firing point. Shortly after the infantry detachment began its assault, it was engaged by 3 unidentified aerial vehicles approaching from the northwest. The unmanned counter-strike team immediately initiated electromagnetic countermeasures. As enemy drones penetrated the defensive perimeter, A net capture team quickly launched its response. While maneuvering undercover, the drone operator aimed a net capture device at the incoming aircraft to disable and bring it down. The infantry detachment then continued its advance into deeper positions. At another training site, a simulation exercise focused on countering drone attacks and improving UAV defensive measures is underway. Personnel practiced shotgun ambushes, electromagnetic interference techniques, and the use of protective netting to mitigate hostile drone activity. To meet operational needs, anti-UAV training is conducted for both individual soldiers and team-level units. The training explores three approaches: evasion and protection within the battlefield environment, the use of simple improvised equipment, and technologically enhanced defensive measures to strengthen counter-UAV capabilities. On the southeast coast, a brigade of the Eastern Theater Army is conducting live flight training with a specific type of UAV. Inside the shelter, scouts record UAV parameters in real time and track key signals, while outside, meteorological personnel monitor temperature and humidity to support safe flight operations. All parameter data is reported to the commander for unified verification, followed by cross-checking between the primary and secondary operators. Only after all three parties confirm the information can the UAV proceed with takeoff. Coastal regions present a more complex electromagnetic environment. Once airborne, the UAV's data transmission can be affected differently depending on location and altitude. Suitable flight routes can only be determined through accumulated experience from multiple missions. Actual UAV flight training includes both unmanned and flight operations and exercises involving electromagnetic confrontation. When the UAV deploys its recovery parachute and lands, the live flight training session concludes. Each UAV launch feels, in a way, like sending a child off to school. After every recovery, there is always something new to learn. Since graduating in 2016, Yang has dedicated himself to the UAV field, growing from a newcomer to someone capable of coordinating and directing multiple specialties to complete training tasks. He expects everyone to approach each drone mission with the same care and focus as if it were their first flight. The next phase of development will emphasize studying the communication patterns and operational behaviors of potential adversaries, including equipment performance, signal characteristics, and tactical applications to further enhance operators' ability to detect and interpret signals. A brigade of the 71st Group Army in the Eastern Theater organized a composite battalion to conduct a comprehensive exercise involving unmanned combat systems. In northern Jiangsu, an assault operation is currently underway. During the engagement, drones and unmanned ground vehicles moved ahead to survey the area designated for occupation. After confirming the situation, unmanned assault vehicles and obstacle-clearing teams worked together to break through the defensive line. The deep penetration team advanced using unmanned assault vehicles in coordination with infantry fighting vehicles, completing their mission ahead of schedule. With the support of unmanned systems, frontline obstacle-clearing efforts became more precise and efficient. The operation also employed a mixed formation of unmanned platforms and armored infantry squads, with infantry providing cover for unmanned systems, improving obstacle-clearing efficiency and reducing risk to personnel. To fully leverage the advantages of unmanned systems, it is necessary not only to equip the hardware, but also to update the mindset of frontline operators. The unmanned combat force has evolved from a single capability into a modular formation integrating manned and unmanned elements, shifting operational thinking from platform-based actions to system-based coordination. As new models are tested and tactics refined, efforts continue to advance unmanned systems from supporting roles toward more central operational functions. Units are increasing unmanned systems training while also fostering innovation through maker studios and talent pools. Encouraging technological development, that enhances operational effectiveness and cultivating technically skilled personnel capable of solving complex challenges. In a live combat exercise organized by a division in the Xinjiang military region, multiple types of drones developed by the division's UAV studio were deployed across different phases of the operation. These systems demonstrated capabilities such as resisting electromagnetic interference, supporting guided strikes, autonomously identifying targets, and conducting long-range precision engagements. These innovative developments not only strengthen tactical coordination and reduce casualties, but also bring training environments closer to real operational conditions, making each exercise feel highly immersive and realistic. With support from the Drone Development Studio, officers and soldiers repeatedly refined and evaluated the design plans. From conceptual modeling to 3D printing, from assembly and calibration to test flight evaluations, the entire process is independently completed and fully original. Efforts focus not only on improving fundamental UAV performance such as endurance and cold weather resilience, but also on ensuring that UAVs can operate quickly, efficiently, and accurately in the plateau's complex electromagnetic environment. The application of scientific and technological innovations has also led to the development of new tactical approaches. Units are currently optimizing and upgrading man-in-man collaborative tactics based on these advancements. Today, new quality combat capabilities have become a decisive factor in determining the outcome of conflicts. The innovative capacity of grassroots personnel is itself a form of combat power. It is essential to support and encourage this enthusiasm for innovation by providing platforms, addressing challenges, and helping grassroots creators realize their ideas so they can continue contributing to the advancement of military capability.